Hello students, today I want us to consider this question from Cambridge International AS and A-level paper. This Cambridge Assessment International Education, and the paper is Mathematics Paper 2, that is Pure Mathematics 2. The code is 9709/23, which was taken October-November 2023. Now, the question that we want to consider is that of integration, and we find it in question 3. So the question reads, part A, find the integral of 4 over 2x minus 5 within the limits 4 to 10, giving your answer in the form ln A, where A is an integer. That's 4 marks. Then B, find the exact value of the integral e raised to power 2x minus 5 within the interval 4 to 10. That's 2 marks. So those are the questions that we want to consider, and straight away we see what the solution looks like. Well, our question is that of integrals, and we have the integral of 4 over 2x minus 5 dx. That's what we want, from 4 to 10. So the limit is 4 to 10. Find that integral, giving your answer in the form ln of A, where A is an integer. That is 4 marks. That's part A of the question. So for us to find the solution, one first step that we need to take is let u be 2x minus 5, the denominator here. That will mean that du dx is 2. And if this is so, then it should also mean, if this is this, then looks like we are saying that du is equal to 2 dx. Therefore, making dx the subject here, we end up with du over 2. So du over 2 here, that is the substitution we give for the value of for dx. So where there is dx, we put du over 2. Now, having that, then we need to change the limits as well, because already we have let u to be 2x minus 5. So the next step is to now define new limits, bearing this in mind. But we have seen that let u be this. So we want to try to get the new limits. So we say when x is 4, u is, so 2 times 4, that's 8. 8 minus 5. 2 times 4, that's it, just a minute. Let u be 2x minus 5. So here we have 8 minus 5, which is, the answer we are going to get is, 8 minus 5 will be, if you substitute here, I'll be having 8 minus 5. So 8 minus 5 is 3. Yeah, 8 minus 5 is 3. 8 minus 5 is 3. Then when x is 10, this, then u will be 20 minus 5, which is 15. So effectively, I now have the new limits for my integral. So I can say from 3 to 15, and now realize I'm talking about du. So I have 1 over u du over 2. That's what I have. Since this dx is now du over 2, and 4 over this, because this is u, now I need 4 outside there. Yeah, like that. So that's what I have for that. So I solve this. But then I need to remember that the integral, this integral here, okay, so let me bring this 2. I can bring this 2 already here. And that will mean that now I have 2. Now I have 2, 3 to 15 over 1 over u du, which will be 2. That will be 2. Now this integral will now be ln u, will now be ln of u. So it's 2 ln of u plus c within the limits 15 to 3. That's what we have. So, but what is u? That then means we need to rewrite it as 2 ln of 2x minus 5, 2x minus 5 plus c. C here is the integration constant. Then I give it the limits 3 to 15, 3 to 15, like that. So that is the solution to that particular part. So next thing that we need to do is what had we been asked to? Where were we asked to stop? Where were we asked to stop? Where were we asked to stop? So without necessarily coming here, well, of course, no. This is wrong because I can't use the limits 3 to 15 where there is x. The limits 3 to 15 apply when here is u. And whenever you see x, the limits 4 to 10 apply. So this is not here. That should be ignored. So the next thing we'll have is to put the integrals. In which case, it will be 2 into, it will be 2 into, so now where there is u, first we put 15. 2 into ln of 15 minus 2 into ln of 3. 2 into ln of 3. That then allows me to write using properties of logarithms. Then I can rewrite this. And how do I rewrite it? It simply means that if this is if the lns have a negative sign here, it means that if we took it to the primal, the original bit, it will be 15 over 3. So I can comfortably write here as 2 ln of 5. 2 ln of 5. That's this result. 2 ln of 5. This result here. And this is like saying ln of 5 squared, which is ln 25. Therefore, our A as required is 25. That's the answer to part A. That is the answer to part A. Now we need to see what part B looks like. And I need to rub this. Rub all this. Yes. Okay, now I have 4 to 10, and it is e raised to power 2x minus 5 dx. And the question has asked us to find the exact value of that particular that particular equation. So again here, first we start by saying let u be 2x minus 5. And the limits will just remain the same way we had them. When using u, then the limits will now shift to 315. So I will write here my integral. I put 3 to 15, the ones we just found in part A, 3 to 15. But now we say e raised to power u du over 2. Because where it's dx, we had seen that there's need to put, where there is x, you replace it with du over 2. So once we are here, clearly we see that we can bring this 2 out, so that I have 3 to 15 this 2 is, it's not 2, it's half. This is half, not 2. Then I have e raised to power u du. But then what is e raised to power u? E raised to power u is just eu. That's what we have. It's the integral, that is the integral of e raised to power u is just eu. And you apply eu plus c plus c. It's just eu plus c. Eu plus c. So that means that here I will have half into eu plus c, like this. Half into eu plus c, like that. Let's now substitute the values. It then means that I'm going to end up with half into, first I take a case when u is 15. So I will write here e raised to power 15 minus e minus e raised to power 3. That's what it is. Plus c. Plus c. And that form of the solution, this form of the solution is what we refer to as the exact value of the integral. So this is the exact value of the integral. Why? It is just as it is. But if we were to find an approximate decimal value, then we would have to raise e. Of course, e is 2.718. We would have to raise 2.718 to power 15, then subtract e raised to power 3 from it and find half of it, in which case it will be a big value, but you're not required to do that. The question is specific that you find the exact value of that integral. So the exact value of the integral is this. So that up to there, that marks the end of this presentation. See you in my next video.